amplitude modulation using SCILAB here. So these are my learning outcomes. At end of this session, students will be able to plot amplitude modulated signal using SCILAB software here. So first we'll understand what is a SCILAB software and why it is used to plot an amplitude modulated signal here. So first we'll start with the SCILAB. What is an SCILAB here? So SCILAB is a scientific software suite that is freely distributed and open source. It is an alternative to MATLAB, which is having a very large amount of fees to be paid for the license. Okay, so the engineering and the scientific applications are benefited from the powerful open source computing environment here, and the researchers from RIA and ENPC have developed it in 1990. So the SCILAB software is alternative to MATLAB, which was developed in 1990 by the researchers from these colleges here. Okay, RIA and ENPC. Okay, so what are the features of SCILAB? So why we are going to make use of this SCILAB here? So the SCILAB main features are like the high level programming language. Okay, and second one is the SCILAB is an interpreted language which can plot the object oriented 2D and 3D graphics with the animations. So we can visualize those output. So that's why the SCILAB have become very powerful and very famous to use alternative to MATLAB here. And it has a dedicated editor also, so where we can write the programs to implement the various simulations and all these things. Okay, and the SCILAB works on the most of the Unix systems including GNU or Linux, or on Windows 7 or 8 or Windows 10 machine here with the Mac operating system. So whenever you're going to do programming in Windows 7 or 8, 10, so it can be used in a Mac operating system also, or in the Linux also. That's why the Linux SCILAB have become more famous to use for implementing the most of the communications protocols. Okay, so now we'll see the interface of an SCILAB here, and we'll see one editor where we are going to write the amplitude modulation program, and we are going to see the basic commands used in that program here. Okay, so now we'll switch over to the SCILAB main interface. Okay, so this is whenever you are going to install the SCILAB. So this is an interface here. So where you are going to install this SCILAB software, so you just go to Google and type SCILAB here. So the website called www.scilab.com will come, where you have to go to the downloads, and you can download the packages which are there on your, which is compatible to your OS. Suppose if you are going to make use of an Linux, then you have to make use of an tarball, or if you are going to install the SCILAB on the Windows machine, so you are going to make use of the exe file here. Okay, so these are the look whenever you are going to double click on this SCILAB, whenever you are going to install. So this is the SCILAB console, and this is the version used for the console, that is 6.1.0 here. Okay, and this is the variable browser, where whenever we are going to take some variables, so all the variables will be located here. So we can see which type of variables are there, like C, that is int variable or float variables like this here. Okay, and these are the command history box here, so where we have taken a few commands that will be stored in its memory here. So which commands we have run previously here. So here we can have the it's like in Python here, so where you can initialize the variables directly here, like x equals to 10. Okay, so now see here, if you are going to make use of x equals to 10, see in this variable browser, that is x is given here, name, value is 10, type is double, and the value visibility is local here, and how much memory is required for that here. Okay, and this is the command history where x equals to 10 we have typed here. Okay, and if you want to browse the file which are associated with the SCILAB, you can browse through this window here, that is the file browser here. Okay, so you can do any type of arithmetical mathematical expressions here, that is y equals to 10, suppose if you type, the same thing will be there here. Okay, then you can type directly x plus y equals to how much, 20, because we have initialized that x equals to 10 and y equals to 10 here. Okay, x plus y will be 20 here. Suppose if you do x into y, so it will be 100, or x minus y, it will be undefined. Okay, it's an underscore here, so it should be minus y, so answer will be 0 here. So all these things, command histories will be there at this position, that is x equals to 10 we have first initialized, y equals to 10, and then x into y, x minus y, all this, and these are the answers variable also is stored here. Now current value for the stack, if you see print the value of an the x and y, it will show like an 0 here. Okay, so these are the basic things. If you want to execute here, you can execute from this console window only. Okay, so now if you want to write some program, okay, so that you have to go to the editor here. Okay, so the editors will be there, so I have just have the editor here. So these are the program used to implement the amplitude modulation here. So in this you can have a open, recent, new, open, all these things you can do. Okay, and this is the run button, execute, save and execute, and save and execute all if there are multiple files are there here. Okay, so this is the program now we are going to understand here. So this is the CLC command used to clear the things which are there on the console here. So suppose if you type CLC, it will clear whatever is there on the console function, on the console box here. Clear, so it will clear all the memory, so what we have used now that, and close means what, it will close all the sessions here if it is previously open any session here. Okay, so that we can see in this console window. If you type CLC, okay, CLC, suppose if you type, so are you sure you want to clear the console? Yes, if you type, it will clear all the console here. Suppose if you type clear, so it will clear all the memory locations. See here, it has been cleared all the memory locations here. Okay, so these are the two commands is used for each and every program whenever you are going to write in SCILAB, because sometimes there are the variables associated with the same program will be there, so they can interfere with each other here. Okay, that's why. So now if you want to see this program, so just recall all about the amplitude modulation. So what are the things required for the amplitude modulation? Okay, how the M is calculated, what are the output of an amplitude modulated signal here, that only we are going to see in this SCILAB editor here. Okay, so here I have taken FM equals to 3 and FC equals to 20. Means what, I have taken the message frequency, that is we know that for plotting an amplitude modulation signal we require two inputs, that is the modulating signal as well as the carrier signal here. So the message signal will be FM equals to 3 and FC equals to 20 here. The same thing what we have done for the taking the amplitude of the signals from the users only. So AM, that is the amplitude of the input signal, enter the message signal amplitude, and AC, that is the input, enter the carrier signal amplitude, that is AC should be greater than your AM here, because your modulation index lies between 0 to 1. So that's why if you want to calculate the M value, then it is M equals to VM by VC, that is AM by AC here. Okay, now suppose if you want to plot the carrier signal or the message signal here, that is the one variable we have defined, that is the message AM into cos 2 pi into FM into T. So this will plot the cos signal here. Now you can take sine signal also, that is the what we'll see the difference at the time of output, if what will happen if you're going to put here sine. Okay, and figure 1, it will be the figure 1 subplot, there will be a 3 rows will be there. Okay, one signal will be there. Okay, one first row in the first signal will be there. Now X label and Y label, we have to label for those things, that is the X label time will be there and Y label will be amplitude here, and title will be message signal. Same way, if you are going to for the carrier signal, the same thing is there. The carrier signal is plotted here with the subplot 2. That will be the second column here in the first, like this. X label, Y label and title will be the carrier signal, and M is calculated. That is, I have taken the variable Ka is equals to 1 upon AC here. Okay. And this is the amplitude modulated signal here. Okay. So for that also subplot, plot X label and Y label here. Now I'm going to run this program. We have to go for the save and execute all. So before that we need to save. So amplitude modulation, it will be .sce file. Okay. So you are going to run this. Okay. So here we are going to get enter the message signal as an input. I'm going to take 2 amplitude of a message signal. Carrier signal I'm going to take 4. Okay. This is an output here. This is your AM signal. See, if you have taken cos signal, so that's why it is starting from this position. If you have taken sine 0, so the sine 0, that is it will start from this here. Okay, cos 0 will always start from -1 here. So this is your message signal. This is the time period, that is fs, what we have seen in the program. This is the carrier signal, and this is your the total amplitude modulated signal here. So in this manner, we need to implement the AM modulated signal. Okay, so in the same manner we can implement DSB SE signal also and SSB signal, that we are going to see in the next video here. Okay, so so in this manner we are going to plot the AM signal here. Okay, so these are my references used for this making this video. Thank you.